All right, today we're going to talk about resultants and relative motion. Okay, you should have already been to the trig review. If you haven't, here's it very, very quickly. You have sine, cosine, and tangent. Okay, also known as SOHCAHTOA. Okay, dealing with the triangle here. All right, scalar versus vector. We already kind of know this. Scalar is magnitude only, or vector is magnitude plus direction. So what we're talking about today is a lot of vectors, okay? A lot of magnitude with direction. So we represent vectors with arrows. Okay, so direction of movie. So let's, for example, you go 8 miles east, and then you go 3 miles north, and maybe 4 miles west. Notice that the longer means more of a distance. The shorter means a shorter distance. Okay, also realize that we always draw them tip to tail. So the tip of an arrow connects to the tail of an arrow. We do not do tail to tail. Okay, just tip to tail. Okay, the resultant is the sum of the first two vectors. Okay, especially with one-dimensional, one-directional example. Very easy. A hiker goes 5 miles east, and then another 5 miles east. I would add those two arrows together to make one big arrow, and it would be equal to 10 miles east. Okay. Then the other example, I go 5 miles east, but then I go 8 miles west. Notice that we made it negative for being west. Notice the arrow sizes. So what am I left with? I'm left with 3 miles west, all right, -3, which is representing west. Okay, two-dimensional. What is the resultant of a hiker that walks 8 miles south, then 5 miles east? At what angle is the hiker's resultant position? So putting in that trig we just practiced plus everything else. Okay, so 8 miles south. So I'm going to draw in this little crosshair over here. I'm going to start in the center, go 8 miles south. I go 8 miles. Then I'm going to go 5 miles east. 5 miles. At what angle is the hiker's resultant position? So we're talking about resultant. We're talking about this displacement, where I started and where I ended. This is going to be my resultant. Okay, we want to know at what angle am I traveling? Okay, well, first off, how do we solve for resultant? Okay, if we have a right triangle, it's going to be Pythagorean theorem, which is a squared plus b squared equals c squared. Or a is one of the sides, plus b, one of the other sides, equals c, which is the hypotenuse, and all of it squared. 8 squared is 64, 5 squared is 25, 64 plus 25 is 89, equals c squared. I want c by itself. I'm going to take the square root. Turn on, square root of 89 gives me 9.43. So c equals 9.43. And I'm going to say miles because the other two measurements were in miles. Okay, so that's how much the resultant, how long it is. Okay, where they're actually going to end up is 9.43 miles from their starting point, but at what angle now? And when we talk about angle, we always talk about the angle from where you started. So I started here, so I'm going to be talking about that angle right there, never this other one where you ended. Okay, always up here. All right, so to solve for this angle, I'm given the opposite and the adjacent. Okay, so I'm going to use opposite and adjacent, which is TOA, so tangent. Tangent equals opposite over adjacent. Tan of the angle, so I'm solving for this angle. So you can either write it as angle, you can write it as x, whatever you want. Okay, my opposite was 5, and my adjacent was 8. Okay, and if I want to get x by itself, or this angle by itself, I need to move tan over. Okay, anytime you move tan over, it flips it. It becomes the inverse of tan. So what I'm left with is x equals the inverse of tan of 5 over 8. So on my calculator, to get the inverse of tan, you're going to say second tan. You do that inverse, 5 divided by 8. My angle, x, or my theta, my angle is going to be 32 degrees. 32 degrees. Okay, but I want to know 32. So I know what direction, I want to know what direction I'm going. So I know I'm going a version of southeast. Okay, because I know I went south, I know I went east. Okay, but if it's 32 degrees, am I talking about 32 degrees here? Or am I talking about 32 degrees maybe up in this direction? Okay, so the way we say that, instead of just saying southeast, we have two options. We can say east of south, or we can say south of east. Okay, and the way this works out is, what direction were you originally heading? I was originally heading south. So the direction you're originally heading gets listed second, so it's kind of backwards. The direction you go second is listed first. So this is like your original direction, and this is your turn. What way did you turn? Okay, so this first one's going to be the winner. So it's going to be 32 degrees east of south. All right, let's do the next one. You travel 30 meters per second at an angle that is 25 degrees north of west. So here we got a weird thing, just like we talked about, north of west. So that means originally we were heading west and our turn was toward the north. So originally, coming over here to my picture, originally heading west, and I'm going to turn and go north. Okay, and I'm traveling 30 meters per second at this angle. Okay, so this is 30 meters per second at that angle, which is 25 degrees north of that west line, north of that west line. Okay, resolve this vector into its components. How far north and west did you travel? I want to know my y and my x, my vertical and my horizontal. Okay, so let's start off with my horizontal. Okay, horizontal. Okay, let's see, this is going to be my hypotenuse, and this will be my adjacent. So I have A and H. A and H is cosine. Cosine of the angle equals the adjacent over the hypotenuse. So I have cosine, my angle is 25, equals my adjacent is what I'm solving for, and my hypotenuse is 30. If I want x by itself, I'd multiply both sides by 30. All right, so I get cosine of 25 times 30. So that adjacent side of the triangle is equal to 27.19. And we're talking about meters per second. So that's talking about this one right there. Okay, now let's talk about my vertical. Vertical is going to be sine, because now I'm dealing with the opposite and the hypotenuse. So O and H, sine of the angle equals opposite over hypotenuse. So sine of 25 equals x over 30. Okay, times both sides by 30. So I get sine of 25 times 30. So my x is equal to 12.68. It's going to be meters per second. So we're talking about that. And that is going with that one over there. Onto the back. Relative motion. So relative motion is motion of the object. Make it so you can see. May appear different depending on the frame it's viewed from. All right, don't worry about that simulation. Link doesn't work. All right, for example, okay, this example, there's a lot of test questions like this, so pay attention. A boat heads straight east across a river with a velocity of 4 meters per second. If the river is flowing south at 3 meters per second, what is the resultant velocity and angle to an observer standing on shore? Okay, so let's start with what started first. So I'm heading east across the river with a velocity of 4. Okay, so I'm heading east across a river with a velocity of 4 meters per second. The river is flowing south at 3 meters per second. What is the resultant velocity? So the resultant is the straight line from where you started to where you ended, kind of like displacement. Okay, so I want to solve for that resultant, and then I want to solve for the angle. Remember, the angle is always from where you started. So this angle right there. So a squared plus b squared equals c squared. Get the hypotenuse. 16 plus 9 equals c squared. 25 equals c squared. Take the square root. The resultant is equal to 5 meters per second. Okay, if I'm solving for this angle, I'm given the opposite, I'm given the adjacent. So O and A, which is going to be tan. Tan of the angle equals opposite over adjacent. So I'm solving for the angle. You can put angle or x, doesn't matter as long as you know that is what you're solving for. Opposite is 3, adjacent is 4. I want to get angle by itself, so I'm going to move tan over. So then my angle is going to be equal to the inverse of tan of 3 over 4. Okay, so second tan, inverse of tan, 3 divided by 4. That angle is going to be 36.87 degrees. And I want to know direction. Okay, so this was east and this is south. So where I went first is listed second. Where I went second is listed first. So south of east. All right, so then how long will it take to take the boat to cross the river if the river is 65 meters wide? Okay, so here's my river. I know I'm going 4. River's taking me down at 3. All right, and I know this is at 5. All right, so when I'm trying to cross the river, I'm talking about this horizontal distance from here to here, horizontal distance. Okay, which velocity is taking me across the river or in the same direction as this displacement that I'm talking about? Okay, and that answer is 4. 4 meters per second is as fast as my boat can go straight horizontal. That's what's taking me across the river with the same displacement, or same direction as the displacement of 65. So now I know my displacement, I know my velocity, and I'm solving for how long does it take, I'm solving for time. Okay, so my velocity is 4 meters per second. My displacement is 65 meters, and I'm solving for how long is it going to take. V equals x over t. Velocity is 4. Displacement is 65. Solving for t, times both sides by t. Now it leaves me with t times 4 equals 65. Divide by 4. 16.25 seconds to get across that 65 meter wide river. Okay, how far down the river will the boat end? So same idea. We're talking about this distance from here to here. Notice my displacement is straight up and straight down. Which velocity matches that displacement? And that's going to be 3. Okay, so we're going to use the velocity of 3 meters per second. I'm solving for displacement, and I know it took me 16.25 seconds to reach the other side. So if I reach the other side, then that's as far as I'm going to go. So same formula. Velocity is 3. Time was 16.25. I'm solving for that displacement, and I times both sides by 16.25. 16.25 times 3. I will have traveled down the river 48.75 meters, and that is going to be just south. I just put an S there for south. All right, hope that helps. If you still need help, meet with your teacher. Have a great day.